Good morning. This is a quick review of the Exam 1 review questions from WebAssign. There's 40 of them, so this video will have the first 10, 1 through 10. I'm going to move fairly rapidly through them, and so this is as a review, not as an initial teaching. So here we're estimating the limit numerically. So we're going to use numerical means, which means with the calculator. We're going to enter this, and we're going to see what's happening as x gets close to -5 from both sides, and that will give us the limit. Now you could also do algebraically by factoring the top, the numerator, and canceling out the x plus 5. But we are going to do it this way because that's how they ask. Again, in this particular one, you'll have test questions that do not need their work shown. If they don't need their work shown, you can choose how you want to go about doing it. So you could do this algebraically, but I'm going to show this method to start with. So there's a numerator. Notice it's all in a parentheses, divided by x plus 5. Close the parentheses. We'll do a quick look at the graph. So I'm going to do a zoom standard, number 6. We see at -5, it looks to be continuous. We know that at -5, it would cause division by 0, so there's a hole there, but it certainly, the graph shows the limit will exist. So I'm going to go to my table set, and I'm going to change it to ask. Okay, so table set is up here, ask, and when I now go to second table, I can enter values. So I want to enter values close to -5 from the left and the right. So from the left, I have -5, oops, sorry, that's 0.5, -5.000001. It's just a little bit to the left of -5. I get 0. I'm going to go just a little bit to the other side, which will be -4.99999. I also got a 0, so notice they're both coming up as if I put in -5. I didn't actually put in -5, because if I put in -5, I get an error. But this number, 1e to the -5, remember that's the same thing as 1 times 10 to the -5. So that means move the decimal place over 5 places here, so we get a 0.00001. We can call that 0. Okay, so on a limit, what we're looking for is what is the y value when we get close to that x value. And both of these are getting very, very close to 0, so our limit is 0. Estimate the limit numerically if it exists. Again, this one, you could do some factoring, but oh, wait a minute, this one's a little different. Notice what our limit is going towards positive infinity. So it's actually completely different. What we want to do is, again, you could do the same process where you put it in and then you just put in very, very large positive numbers. Okay. And the other way is we just look at the two leading terms. So I'm going to do both sort of as a check. So now the only thing we need to really consider when we have a rational function like this is the two largest terms. And I mean largest degree. So this is an x squared, this is an x squared. So it's going to behave like 7/2 x squared, x squared. X squareds can divide and become 1, so it's going to go to 7/2, which is 3.5. Okay, and that's the y value it's going to, and I'm going to show you that that does also work here. So we're going to clear out, I'm going to put this whole function in there, 7x squared. This is a good way, let's see, I need a parenthesis, so I go second insert, which is the delete key. I can insert and then it's plus 9 x minus 2, close the parentheses, divide it out, put another parentheses, 2x squared minus 3x. And again, these are the early on ones that we did. And what we're going to do is we're going to go back to the table, which is already set up in ask mode. We can clear these out, but what I want to do is, since I'm going close to positive infinity, I just want to put a large number. Let's try 100,000. Put in 100,000, I get 3.5001. Let's put in something much, let's put in 1,000,000, or just put a bunch of zeros. Yeah, 3.5. We're getting as close to 3.5 as we want to get. So as we get bigger and bigger, the function is leveling out at 3.5. And again, this is a good way to analyze these. Just look at the largest terms. Okay, try to keep moving here. For this one, I don't think we need the calculator. We're going to change our pen color to red so that we get some contrast here. And then, so this first question is asking, what is the limit as x goes to -4? So here's -4. Hey, there's a function value right here. But again, what it's asking is really, as we get close to 4 from the left and the right, what is that y value? It's 2. It's a y value of 2. Now let's look at the limit as we get close to -2. Now there's a different thing going on here. We've got a discontinuity, it looks like, as we get close to -2, but this time this little plus says it's from the right. So as we come from this direction, our y value is getting close as we want to 2 as well. Okay, we get a different place. So the first one was looking at x value of -4. Now we're looking at x value of -2. Coming from the left, so this time I'm following along the graph here until I get to -2. Okay, I'm getting close here. What is my y value getting close to? It's getting very, very close to 4. Not equal to 4, but very close to 4. The y value is 4. So what would the limit be? Well, you can see right here, the right limit and the left limit are different. So this does not exist. For a limit to exist at a value, both the left and right have to be equal. Is there a function value, though, at f of 2? That's what's saying, just if I plug in f of 2, do I get a value? Yes, we do. It's right here. It's this solid dot. That is actually the function value. When you plug in f of -2, you get the answer +2. So there is a value that exists there. However, the limit does not exist. And now once the limit as x goes to positive infinity, so we're kind of following as x gets really big, and it looks like it does, you know, if we were to follow this, it looks like it's leveling out right here at 6. Okay, so we have to just assume that it's leveled out. So we're gonna follow the graph along here. It's at 6. Okay, so be prepared to look at some graphs and find limits graphically like this and like this. So here's 4, a different one, but same type of process. Okay, so we've got this graph. We want the limit as x goes to 0 from the left, right? Correct? Not left. So from the left, we're coming here. Looks like we're going off to infinity. So we can put that the limit does not exist. Now you could also say, I think it would also accept infinity, but infinity is not helpful here. That's going from the left. Then they want the limit as x goes to 3. Here we are, x equals 3 from the right. So as we come from the right, looks like it's going to 0. The y value is going to 0. Now they jump around. The limit as x goes to 0. Again, I would say that does not exist, but you could also say that the limit is going to infinity. Let's see which one are they going to accept. We'll take a look at this one. So we could go with infinity on both of these. We could also say it does not exist, that it's diverging. Both are accurate ways to represent it. And then we jump back to what's the limit at 3. Well, the limit at 3, we didn't do it, but if we come from the left side, our limit would also be 0. So the left and right, so this was a right limit. It's jumping around quite a bit, but the left limit would also be 0, so I can say the limit at 3 actually is 0. How about the function value at 0? Actually, this was not from the left or the right. Function value at 0, it's actually right here. They assign it to be 0. The y value is 0 as well. And the function value at 3, well, again, it's been assigned right here, so that would be 3. Let me do a quick check on this. And again, I'm kind of having to do this live. So let me put in my answers and I'll bring it over here because I've got this same one open. Let me try this with infinity in here for the A answer. 0 for B. We're going to go with C as being infinity. Again, I would prefer D and E, but let's try this infinity. 0, 0, and 3. Okay, so I'm going to show you I've got the same problem right here. This is number 4. Let's do a check on it. And again, on the test, I will be personally responsible for the grading so I can review. Again, my preference on something like this would be to put D and E, but they accept this. I believe they would also accept D and E, so let's just do a quick check. D and E. Because it does diverge. Let's see if they accept it. I will accept both. It's not the machine because when things go to infinity, yeah, see, it accepts both. So you got a double chance on that one, whichever way you want to stick with. Okay, awesome. So let's keep plugging forward. So that was number 4. And now we get to number 5, similar but an applied problem. So we've got this graph here. There we are. And let's go back to blue because our graph's in red. So we want to find the limit from the left as we get 1475, and you can read through here, that's actually 2:45 p.m. So from the limit, what's happening here is we're following along the graph. When we get to 2:45, we would say the limit is 66. Okay. And the limit does exist. Yes, it does. So we could check that. Okay. This one is the same thing, but coming from the right. So coming from the right, we follow this one from the right, and yes, we're going down. So it's the limit is at 10. The limit's at 10. And we can say the limit from the right does exist. Now the limit at 10.75, since the limit in the left and right are not the same, we would say that the limit going to there does not exist. We have a discontinuity. Not because it diverges, but because the left does not match the limit from the right. Okay. And this final one, what is the function value? Again, we have to look here. It's not as we get close, we come to 245, 1475, and we see there's a solid dot there. The the function value is 10. Okay, so the function value is 10. So now when we read through this just prior to 245, this is talking about the left limit. We were getting close to 66 million shares, but then fell suddenly. What did it fall to? Well, it fell to this function value here of 10. And then immediately following, so just after it, what's happening? We're talking about the right-hand limit, which is also 10 million shares. Okay, so don't go too far, because immediately after still means we're in this neighborhood, so it's still, we consider it 10. It's the limit as we're very, very close to 245, but just on the other side. Yes, it is going up, and you might say, well, it's going to this value, or it's trying to get up to 100. No, that's not immediately. That's a long time, an hour, 2 hours, something like that. So it's immediately there. Okay, so that's the answers for that one. Halfway through this video so far. So now use a graph for f or some other method to determine what a value to assign to f of a to make it continuous at x equals a. So we're trying to make it so that it's continuous at -8. So notice if we plug in -8, we get a 0. We get a discontinuity here. So they suggest using a graph. We could do that. The other way we could do is with algebra. So maybe I'll do the algebraic. We can factor this out. So in the numerator, you can factor out an x, and you're left with x minus 4. Is that going to help us? I don't think so. The denominator, you get x plus 8. So that doesn't really help us. So let's go with their suggestion of using a graph. Let's clear that out. Parentheses, x squared minus 4x, parentheses, divided by, parentheses, x plus 8. Yeah, it could be, since there is no canceling, it could be that there is no such value. We'll see here pretty quickly. If we get some asymptotes, which I think we're going to get at -8, then we're not going to be able to do this. So I'm going to do a standard zoom, again, getting my window from -10 to +10. So we're looking at -8. Looks like it's going off to infinity that way. Where's the rest of this graph? Let's go to table. Let's put in -8. Just see, it should be undefined. It is. It gives us an error. Let's go back here. Let's go to window, and let's make our y value larger. Let's go to 100. See what's happening there, and maybe make our y minimum -100. So that we can, yeah, okay, so it's way down here. So what we see is with this graph, at -8, one side, the left side's going down to -infinity, the right side's going up to -infinity. You cannot connect -infinity with +infinity by making a equal to a value. So in this case, the graph is pretty clear. It was a little complicated to see it. There is no value. So we put none. There we go. Let me just move my window a little bit. So I'm going to do my x minimum. I'm going to go to -20 so you can see a little bit more of the graph. And let's go -200 to +200 just to zoom out a bit. You'll see this. So we see this dropping down. Oops, I think I only went to 20. What did I do with that window? Yeah, I only went to 2. Let's go to 200. Let's center it a little bit. So we've got this graph, it goes down at -8, and at negative 8, this one's coming from positive infinity. There's negative infinity. There's no way to hook these up. Okay. Calculate the limit algebraically. Okay. So you might notice this from our discussions. This is a closed form. It's just a polynomial, a quadratic. So we're actually able to do this by just plugging in the value of h. Now, this h is just a variable. It's just like it could have been x here. So it's not that special h that we're trying to let to go to 0. This is h going to 4. So we put 4 squared plus 3 times 4. And I'm just plugging in 4. That's what we're able to do when we have a closed form function. So that gives us 16 plus 12 plus 2, which is 14 plus 16, which is 30. The limit does not exist because it diverges. No, the limit does not exist. The limit does not exist. The limit does exist and is a finite number. So that's what we can say about this. It does exist and it is a finite number, 30. Okay. If the limit does not exist, say why. I don't, but I should have asked differently. Anyway, that's 7. We're almost here. 8. Calculate the limit algebraically. Okay, and again, if this is an open, this is not one of the ones you have to show work for, you can do this in any way and you'll get full credit. Algebraic, since they asked for algebraic, the work should be algebraic. However, the answer will get you there too. So looking at this, again, we're going to 0, not infinity, so we can't just take the 2 largest terms. We're letting x or h go to 0, which would cause division by 0 here, would cause 0 on the top. So we had a rule that when you get, right now we analyze it, we get 0 over 0. Let's algebraically factor out an h from each of these. So in the numerator, we get h, 8h plus 1. In the denominator, we factor out an h, and we get 2h plus 3. H divided by h is 1, so that becomes 8h plus 1 over 2h plus 3. And again, we're looking at the limit as h goes to 0. So we can let h become 0. Actually, just plug it in. Let's see what we get. We get 1/3, right? This is 0, this is 0, this is 1/3. So we could say 1/3 is our answer. The limit does exist and is a finite number. And that's algebraically. Okay. Again, if you were to go ahead and graph this as another sort of process, you could see that this would basically have a hole at 0. There would be no value there, but the limits on both sides would be getting very close to 0.3333 when you looked at your graph. Okay, 9. Calculate the limit algebraically. Again, another practice at this. So when you have 2 problems of the same type, you probably can count that something like this is going to be on your test. So what we want to do is a factor. So let's go ahead and move this, because if you plug in -1, let's see. If we were to plug in -1 down here, this gives us a +1, -1, so we get a 0. In the top, we would get a +1, we get a -11, +10. We'd also get, so we do get 0 over 0. When that happens, we're able then to do a reduction. Okay, so let's, the numerator, well, the denominator is a little easier to factor, take an x out, so then we have x plus 1. The numerator, let's see, how does that factor? I'm going to use it, so it'd be nice if there's an x plus 1 in there to cancel out. So I'm going to say that there's probably an x plus 1. What do 1 times what is 10? So that must be 10. There's an x here. Let's see if that works. That gives you an x squared 10x, 1x, you add those together, you get 11x, and 1 times 1 times 10 is 10. So this is it. So we can reduce this fraction. X plus 1 divided by x plus 1 is 1. So now we're left with the limit as x goes to -1 of x plus 10 over x. So we can just evaluate this at -1. So that's -1 plus 10 over -1. That gives us 9 over -1, which gives us a -9. Okay, so the limit does exist, and it is a finite number. Again, graphically, if we did this, we would see a graph that at -1, we got some kind of a hole, but the graph itself would be coming down like this. There would be something, or up, something, but we'd have a hole here at -9. So we'd be able to plug it if need be. Okay, something like that. So look at it graphically. Last question, and then move on to the next video. Calculate the limit algebraically. If an answer does not exist, enter DNE. So algebraically, there's really nothing we can do here. As x gets close to 0 on this side, what's going to happen? Well, we're going to get closer and closer to infinity. Okay, so I don't know that there's really anything algebraically we can do with this, but we could look at the graph, and it's going to go like this, right? So let's at least from that side, and that's really all we're interested in, is from the positive side. So let me graph this. Yeah, there's nothing algebraically, I guess, that we can really do with this, except say that, well, when x goes to 0, we get, they had somewhere we could just compare, and that this is like some constant over 0, and then they just say, well, that goes to infinity. Okay, I think that's what they're thinking of doing. And all the graph is going to do is verify that. But since we're already here, let's go ahead and do that. Let me zoom back to a standard window. Yeah, see, it's going down to -infinity on this side, up to positive infinity. So with this one, we can put in a DNE, and the limit does not exist because it diverges either to positive or -infinity. So now this part, I believe you can also get correct if you put in infinity, but in this part you have to say it diverges. The limit does exist because it approaches, which you could use that side, but it diverges, okay? And actually the left goes to a different infinity than the right, so definitely a divergent. Okay, so this is the end of 10, and I'm going to take a little break, and then I'll start working on the next 10 and see how many we can get pumped out today. Do your studying, prepare well, review these. Hopefully you've already gone through these, but any questions you have, hopefully I'm getting them answered for you. Thank you, and I'll make the next 10 here shortly.